Hello everybody, it's Ahmed Vinez. Today we're going to be trying the Maclaurin. We're going to be trying to find the Maclaurin and the interval of convergence of f of x is equal to 1 over 1 minus x. So Maclaurin series and Taylor series, I think those you can probably search up on your own. The definition, I'm not going to take the time to explain it. But if just the one thing, Maclaurin series is basically a Taylor series, but it's centered at c is equal to 0. So I'll just quickly go over the formulas. So Taylor series, so I'm just call it TS. That's basically just f of the derivative n, the n derivative of n of c, that's our center, times x minus c to the nth power divided by n factorial, and that's basically what it is. And then that's for the nth term, of course. That's how you find the nth term. And then going on, you have Maclaurin series. Basically, the c gets substituted of 0, so x minus 0 is 0, so it becomes x to the n, like that. So let's start trying this. So you got 1 over 1 minus x. Oh, right, interval convergence I'll teach when I get there. 1 over 1 minus x, so we need to find it. So let's go over the derivatives. So we know f of x is equal to 1 over 1 minus x, which I'm going to rewrite for now into 1 minus x to the negative 1. And we need to find f prime of x. Now remember, chain rule applies here, because it's a derivative. So the chain rule would be just basically this similar 1 minus doing the regular derivative rules, minusing a 1 and multiplying that there. But then remember, inside here the derivative is negative 1, so you times that as well. So negative 1 times negative 1 is just 1. So that can become taken out. Now the second derivative is just equal to derivative of that. So that's going to be negative 2 times, remember we're going to actually start every one with negative 1, because remember the chain rule. So times negative 2 of x, 1 minus x to the negative 3. And it's basically, so that just becomes 2 times 1 minus x to negative 3. Now the third derivative is just going to be, well, you're going to multiply that. So it's going to be negative 1 times that, which is negative 6 times negative 1, which is 6. Then you're going to minus 1. Negative 4, and then it's going to keep going on. So you're just going to basically have these terms. Now remember, our Maclaurin series is centered around 0, so we have to plug in x equals 0. So what will we get? So that means f of 0 is equal to, well, we plug in 0 there, that's going to get 1. Now f prime of 0, you're going to plug in 0 there, that's also going to get 1. The double prime of 0, you're going to plug in you're going to plug in 0. Sorry, did I say 1 there? Sorry, I meant 0 there, and you're going to get 2. F triple prime of 0, and you're going to get 6. So you can see basically this thing here is always going to be 1, so it's just basically what the coefficient is. So we have this really important information there. And remember, we can go back to our formula. So remember, our formula is just basically sigma to find the actual whole series. Sigma n equals 0 f n of 0, f of n of 0 times x to the n. But I'm going to keep this here because it's going to be all the integers there. So let's start with the first one. Just try 0 factorial. So we got the 0. Sorry, not 0 factorial. Yeah, but n is equal to 0. So the bottom 0 factorial, remember, is 1, not 0. And then f of n is 0. So the f of 0, which basically, remember, this is just a 0. And this is 1, and then 2, and then 3. It's almost like tallies. So that's equal to 1 times x to the 0. So that's just 1. So we know our first term is 1. The second term is, well, the second term, but it's technically the second term in our series, but it's but when you start in a Maclaurin series, you start with the 0 it's 0 term instead of first term. So our first, when n is equal to 1, I'll say, so the derivative, so that's going to be 1 over 1 factorial is 1 times x to the 1. So that just gets you x. Then 2, so that's going to be 2 divided by 2 factorial, which is 2, x to the second, so that's going to be x to the second. You may see a lot of pattern here, but let's keep going until we get there. So third prime, so that's going to be just 6 divided by 3 factorial, which is 6, and that's just going to be 6 over 6 times x to the third, which is just x to the third. So you could see actually this, our series is just a continuation. It's just due to x to the infinity. So that's basically our thing. So we need to find how can we express this like in this form. So let me get infinity. Uh, infinity. So yeah, how can we express this in sigma form? X is 0. Sorry, n to the 0. I'm bringing it out a little bit. So because we're starting n to the 0, remember x to the 0. If it's going to be x to something, because that's what we are been seeing as the pattern. X to the 0 is 1. So that's basically x to the 0 plus x to the 1 plus x squared plus x to the third. Keep going on. So it just turns out it's just x to the n, and that's our actual Maclaurin series. Now we're going to go to our IOC, our interval convergence. So our interval convergence, you can first by doing you can calculate by doing the ratio test, which is basically just the limit as n approaches infinity of you're gonna say a to the n plus 1 over a to the n, basically. Let's call it our series. We can call this a, and like that. So that's just going to be x to the, because it's n plus 1, we plug in x to the n plus 1 divided by x to the n. Remember, that's just equal to, you can minus it, so that's just equal to x, the absolute value of x. So remember, the limit as n approaches infinity of x, remember, we're trying to find n here, this has x, so anything other than, so anything with that is not a variable, didn't write my screen. Anything that's not the with the variable n, it can still be a constant here, but anything with not is going to go outside the limit, so that's going to be there, and then because we took that out, it becomes 1 here. So as n approaches infinity, well, it's still staying 1, so this is just 1. So it's this times 1. That's equal to that. Now, how do we go from there? Well, in the convergence, ratio test, this has to be less than 1. That's the rule. So then, of course, you can just solve that so that if you can take the absolute value out, the x is less than 1 and x is greater than -1. So technically, our interval is -1 less than x less than 1. Now, that's not it though, because remember, even though we said that, there can always be here, you have to always check, because sometimes -1 or 1 can be included in the interval. So to check if they're included in the interval, their endpoints, we need to check inside that series. So remember, our series, we said, was x to the n. As n approaches, that's not where you're supposed to put it. N equals 0 and infinity. So we need to plug in these values for x. So let's plug in -1 first. So -1 to the n of that n equals 0 and approach, sorry, you're not supposed to have n approaches infinity there. Just put infinity. Now this is just the so you need to know this is where you get into a little bit of a convergence series test, but honestly you really don't need it. But let's use a convergence series test. Basically, remember it's a convergence series -1 to the n or n plus 1 whatever times some bn. So bn is 1 here. So I'm just going to say times 1 to just make it. So we need to, with the alternating series test, we need to check if limit as n approaches what was it again? Limit as limit as n approaches infinity of 1, is that equal to 0? Well, of course not, because it's still going to be 1 all the way. So that is equal. So this means that it doesn't converge, because already the first condition is the two conditions have to work. The first condition already doesn't work, so we know that this series diverges. And remember, we have our interval of convergence. So that means that -1 is not supposed to be included in the interval. So we know on this less or equal to sign, you're not supposed to have a line under it. Let's try for the second endpoint, and then we can go from there. Sigma of n equals 0 infinity of 1 to the n. Remember, it's x to the n, so 1 to the n. Remember, of course this diverges, because just think about it. It's always going to be 1, so it's just multiple 1s being added up in a summation. And if you're having infinite 1s in here, then it's just 1 times infinite, which is just basically infinite. I mean, it's not, of course, I don't know if that's exactly proven, but you get what I mean. It of course doesn't work. I mean, it's just like a lot of it is intuition. You can't really use like all this convergence tests. So we know that this one also diverges, because infinite means diverges. So this one is also not including interval. So we did not need to do anything to this interval. That is also our IOC. So a reminder, so we tried to find the Taylor series of 1 over 1 minus x. The Taylor series for that is TS that's sigma from n equals 0 to infinite of x to the n, and then our IOC was -1 less than x less than 1, or it can also be expressed as 2 parentheses -1 1. Thank you for watching this video.